That, and the next one is once you this was about about the segregation. Next comes the bleeding of concrete. This is the fourth property, main property of concrete. So now, what is bleeding? Bleeding is the water gaining. Bleeding is actually its water gaining property. So is it water gaining or water losing property? It looks like it's gaining water at the top surface. So that's why it's the name here. So what now, if that water is not evaporating, so we presume it's the bleeding of the concrete. So it's actually gaining more water. It should not gain that much amount of water. So how you can say it's the water rising to the surface as well of the concrete. So when does this happen? When you have a bleeding, bleeding would happen more when you have more segregation as well. So it comes up towards the top as a latence, which is known as a latence, a cement and water paste going towards the top. So it comes up as a patent. So what happens due to bleeding? There's a pore bond development once bleeding happens, because most of the cement paste comes towards the surface along with water. So inside there is less water, so there is pore bond between the concrete, and then pore bond even between concrete and steel if there is steel inside, because some of the bleeding water may remain here. This, for example, this is a beam, और बीम में एक लोहे का बार ऐसे होता है, something like this. Then in that case, you would see that once the water is rising towards the top, it will be stopped by this reinforcing bar at times. तो इसके नीचे सीमेंट का पेस्ट जमा हो जाता है at the bottom of this. So that is actually underside of this reinforcing bar of the steel bar. इसमें ये steel bar है concrete की beam में. So actually we don't want that to happen, because there are then less aggregates below the bar, so it's not offering the total strength. So there is, and it's the aggregates which are actually acting as the bonding between the bar and the concrete, because they interlock with the aggregates interlock with the ribs in the steel bar. आपने देखा होगा एक स्टील का बार होता है, उसमें रिब्स जैसे होते हैं ऐसे. I can show you. You have seen this. These are the steel bars. There are ribs. These are ribs. बाहर से ribs जैसे बने होते हैं इसमें. So these actually interlock with the aggregates. So if there are less aggregates and more of concrete paste there at that point, then you will not get a proper bond between concrete and steel. So you do not want that to happen. The next, what is happening? When does the bleeding become more? When the cement is fine, you are using finer cement, then the bleeding becomes more, because more of the finer cement will become suspended in water and it will travel up. You do not want that to happen, so you have to restrict the fineness of the cement to which we have already discussed. So smaller particles of sizes less than 150 microns, they reduce bleeding. Now this is about the aggregates. So if you have small particles of aggregates of size, that's the fine aggregate, 150 microns around, that reduces bleeding. Now if you are using large size particles, then in that case what is happening is that the sand particles, they will not form a consistent paste with the cement, so the bleeding with the water will happen. Then there is one more thing, the rich mix. They are less prone to bleeding because their rich mix means there is two types of mixes, lean mix and rich mix. A rich mix is that mix where you have more amount of cement, or you have more amount of pozzolanic material, or you have more amount of high grade cementitious material. Now in the pozzolanic mix, because you have a fly ash and other things added to the cement, they are actually not they are actually becoming more hydrophobic at the same time, the pozzolanic materials, along with not becoming suspended easily with the water, because they achieve hydraulic strength much more quickly, so the bleeding is less in that case than in the case of the lean mix. And there are less gaps in rich mix concrete. वो rich mix जितना, rich mix means more strong concrete, जितना strong होगा उसमें उतने gaps and voids कम होंगे, so the water and this will not have any path to move towards the top. All the small gaps are filled up with cement and with fine grade sand. They will fill up those voids in the rich mix concrete. So coming to one thing related to bleeding is mixer, which I just discussed earlier. You do not mix more than 5 minutes, but to prevent bleeding, you do not go for even mixing greater than 1.25 minutes. For a normal grade concrete in a mixer, you should, to prevent bleeding, क्योंकि जितना आप मिक्स करते जाओगे पानी उतना अलग पहले ही, बिफोर इवन प्लेसिंग फ्रॉम अ बकेट ऑन टू द साइट, वो पहले ही पानी अलग सेपरेट हो गया होगा ड्यू टू excessive mixing. So for preventing bleeding, it's recommended you do not exceed 1.25 minutes of mixing within the mixer. And if it's a high speed mixer that you are using, there 35 seconds is enough of mixing. But if you are using lightweight aggregates, there the chances of segregation as well as bleeding are less, so you can go up till 5 minutes of mixing for lightweight aggregates. Anyone who has any questions up till this point?
Excuse me, sir. So what is the difference between stiffness and hardness?
I explained this once. You have stiffness, which is the early resistance. It's not in the solid form yet, not solid. It's not, it's in the plastic phase. Okay, now plastic phase is you can still mold it into certain things, so it's in the plastic phase. It has not become solid as of yet. So stiffness, you are measuring its resistance when it's plastic. Hardness is it has become solid, it has achieved its final setting time. Its stiffness, now you don't classify it as stiffness, you classify now this as its hardness, or you can say it's toughness. कंक्रीट में हम टफनेस कम इस्तेमाल करते हैं टर्म, एंड स्टील में ये टर्म ज्यादा इस्तेमाल करते हैं, और इन मेटल्स we use the term toughness more because there you check the toughness by an impact test. An impact test is by, for example, you bang it with a hammer. So that is toughness. But in concrete, you do not do that in checking the hardness, because still its hardness is, or its toughness is less than in the case of metals. So you do not bang it with the hammer by an impact test when you are doing the hardness test. You are checking it with the strength test. So you are using instruments which are not impacting it. Yes, there are certain non-destructive tests like a rebound hammer test, which actually measure the hardness of concrete. That's rebound hammer test. It's actually checking the hardness of concrete. I'll show you the picture of the rebound hammer test, how it checks the hardness of concrete. By it's a non-destructive test. This is a rebound hammer test. It's using an impact is being used, but it's a point impact, a small point impact being used onto the concrete. It rebounds onto the surface of the concrete at one particular location, and you are checking the actually the hardness of the, once the concrete has become hard, you are checking that, and you can then relate it with the strength as well. From this test, it's related with the strength. Once the building has been already formed, you cannot, there is no other way to, मैं building में concrete की strength check करना चाहता हूँ, तो कैसे check करूँ? This test is being used to check the hardness, and then it's related with the strength. So is it clear?
Yes, sir.
So next comes the vibration. This is not a property of concrete, but this is a side thing I am discussing. Now, how much vibration? Why do we do vibration? I wanted to discuss this in a little detail. This is compaction or consolidation, which I just discussed to you, that you want to achieve in concrete, or the densification you want to achieve in concrete. So what do? You ram the concrete. The easiest way to achieve the compaction is by ramming of concrete or by fuming of concrete. That's the easiest way to achieve the compaction or the consolidation. I'll just show you the picture. How do we ram? You must have all seen, but I want to give you an idea. What do I mean by ramming? The ramming of concrete. एक small log लिया जाता है. This is the easiest and the simplest way. एक log is taken, tied it with two rods, and it's then used in just ramming the concrete surface such that it compacts, it consolidates, ताकि ये dense इसकी density achieve हो जाए. You must have seen the ramming of sand being done. This of the sand being done, this one. You must have seen this, or of the clay being done, or to compact. The ramming or fuming is almost the same thing. You are actually taking out the air bubbles from concrete. So 5 to 20%, 2 to 5%, you are the air bubbles in concrete, and you want that to be restricted to this 2 to 5% at the maximum. You want that to be removed, even that to be removed. So you want to achieve it to the lower limit of around 2% and even lesser. So for that, the compaction of the concrete is done, so that those air bubbles will come out before it begins to set, and thereby it begins to densify. So this is the simplest way to compact the concrete. But then you have internal vibrator, which I discussed the last time, where you use the poker or use the needle vibrator. I discussed this already. And now about this, there is one important thing. You have to, the limit The range of vibration is 3000 to 5000 cycles per minute for this internal vibrator. And we usually go at maximum to 12,000 cycles per minute in extreme conditions, जहां पर बहुत ज़्यादा vibration देने की ज़रूरत है. There is a huge structure and the concrete is not of consistent paste. The concrete is not having much plasticity. उसमें ज़्यादा plasticity नहीं है, तो वो workability उसकी कम है. So we have to increase the vibration. In that case, we might have to increase up till 12,000 cycles per minute through the internal vibrator. I've already showed you this, the internal vibrator, the last time. Motor here and the maximum. Now this is known as internal or the poker because you have the needle of this going into the body of the concrete. So it's actually vibrating even to the bottom depths of the concrete. You want that. This is a much better form of vibrating the concrete. Then you have the external vibrator. Even this I discussed the last time, but I just want to tell you the number of cycles that's limited between 3000 to 6000 cycles minute के हिसाब से external vibrator runs at this. I've already shown you the external vibrator for concrete. And there are even more. I'll be showing. One, I showed you the vibrating table, which is the external vibrator. Then there are these. Now they are put onto the formwork from the outside and the vibration is done from the outside. So the particles begin, which are actually sticking to the formwork, they also begin to settle down to their respective places. And you do not want the particles to stick to the surface of the formwork. You even use this for that purpose. क्यों? क्योंकि formwork फिर उठाना मुश्किल हो जाता है. It sticks such, if it's a wooden, it sticks more. तो वो उसके साथ चिपक जाता है फिर. You must have seen slabs के नीचे हम बिल्कुल ऐसे ही प्लाईवुड की पट्टी वहीं पर रह गई. और वो फिर निकालना बहुत मुश्किल हो जाता है. You don't want that to stick. And to prevent that sticking, what do you use? You use greasing and oiling of concrete before placing. So the shuttering is done. This is like this. You are actually oiling through spraying or onto the shuttering, onto the shuttering or to the formwork. Yeah, and you can just apply the oiling through admixtures. Now, this is one more component that you are adding to the concrete, the admixtures. Now, why do we use admixtures in concrete? This is actually to change its physical characteristics. Admixtures have certain physical benefits to the concrete. Now, in physical characteristics, you mean you are changing the compressive strength, you are changing its hardness and toughness, you are changing its setting time. So these are the physical characteristics of concretes and that you want to change. So for that, you are adding the admixture to the concrete. Now, one is that. Another is it will have certain economical benefits. It might have certain economical benefits. That's why you are adding the admixture to the concrete. So what is an admixture? First of all, it could be classified into, as per ASTM, which is American Standard Testing of Materials. They classify admixtures as type A, type B, up till type G. Up till type G, you have type A, B, C, D, E, F, and G. These are the types of admixtures they classify. Now, what are these classes? Type A is water reducing admixture. Type B is retarding admixture. Type C is accelerating. Type D is water reducing and retarding both. Type E is water reducing and accelerating. Type F is high range water reducing, or you can say it's super plasticizer, another term for the high range water reducing. Type G is high range water reducing and retarding at the same time, or super plasticizer and retarder. So these are the various types of admixtures that are used. Now I'll come to these one by one. Once probably I will not go to all of these, but the important ones being the base core one, which is retarding, accelerating, water reducing, and high range water reducing, which is the super plasticizer. Type D, E, and G are combinations of the rest. The rest of all, they are the combinations that you obtain from type A, B, C, and F से combine होके type D, E, and G बनता है. So usually admixture is in the liquid form. It's used in the liquid form because it mixes well with concrete when it's in the liquid form. But there are admixtures which are also present in the solid form as particles or as fibers or as um, a small chips. It may be in that form as well, in the solid form. Now, what decides the dosage of admixture in concrete? So we have discussed till now that concrete is a composition of fine aggregate, then you add the coarse aggregate, then you add water and cement, and now you are also adding the admixture. It's an add to the mixture. So the name admixture. Now you are adding it either in liquid form or in solid form, and the effect of this will be the change in the properties. So you always add admixture to improve the properties. You do not add the admixture to decrease its benefits of the concrete. You increase the benefits of concrete. So the effect is a positive change by adding the admixture. It should be always the positive change, but there might be certain admixtures which have both positive as well as negative effects. Now, what is the situation in which you are using and what is the benefit of it in that situation? वो हमें देखना है. तो क्या उस टाइम पे बेनिफिट कर रहा है उस सिचुएशन में? अगर कर रहा है तो वहां पर हम वो एडमिक्सचर यूज करेंगे. अगर उसके नेगेटिव इफेक्ट्स उसके पॉजिटिव इफेक्ट्स है उस सिचुएशन में, तो सिचुएशन आल्सो डिसाइड्स एनवायरमेंटल कंडीशंस डिसाइड, टेम्परेचर डिसाइड्स, ह्यूमिडिटी डिसाइड्स, आप कहाँ पर प्लेस कर रहे हो कंक्रीट को वो डिसाइड करता है। तो वो क्या नेगेटिव इफेक्ट्स, अगर पॉजिटिव इफेक्ट्स से ज्यादा है तो देन यू डू नॉट यूज दैट एडमिक्सचर। हाँ, अगर आपकी नेगेटिव इफेक्ट्स पॉजिटिव इफेक्ट से ज्यादा है इन टर्म्स ऑफ स्ट्रेंथ, और लेकिन आप पैसे बचाने के चक्कर में हो, एडमिक्सचर ऐड करने के बाद पैसा बच रहा है आपका, दैट्स नॉट एडवाइजेबल। इकोनॉमिकल बेनिफिट्स माइट बी देयर बट वो एडवाइजेबल नहीं है। You do not decrease the strength, you do not decrease the durability of concrete at the expense of पैसे बचाने के चक्कर में। So, what is the right dose of admixture? That is decided by the right dose decides the benefit. ज्यादा कहते हैं ना, excess of everything is bad। अगर आप admixture भी, जैसे हमने सीमेंट, वाटर, कोर्स एग्रीगेट, फाइन एग्रीगेट्स में देखा, एक लिमिट है, एक रेंज है, तो वैसे ही एडमिक्सचर में भी एक लिमिट है। देयर माइट बी पॉजिटिव बेनिफिट्स ऑफ एडिंग एडमिक्सचर बट अनटिल अ सर्टेन टाइम, उसके बाद बेनिफिट्स से ज्यादा नेगेटिव इफेक्ट्स उसमें आ जाएंगे। सो यू हैव टू check the right dose. So it's also influenced by, dosage is influenced by mostly by the temperature. टेम्परेचर कितना है वो डिसाइड मोस्टली करता है कि क्या राइट डोज है इन अ पर्टिकुलर सिचुएशन। तो पहला है एक्सेलरेटिंग एडमिक्सचर। First one is the accelerating admixture. Now, accelerating means it is accelerating the hydration process. So it's achieving the early strength development is happening. It's accelerating the accelerating term, you know, it is increasing the early development of strength due to increase in the early hydration. Finally, it may also hardening of concrete may also develop by adding this accelerating admixture. So it is setting the concrete as well as hardening it. It's accelerating both setting as well as hardening. Now, where do you use early setting? In temperatures, use कहाँ पर है? जहाँ पर टेम्परेचर अराउंड 2 से 4 डिग्री के करीब है, 2 to 4 degree Celsius, there you might use the accelerating admixture. उससे कम तो freezing point आ जाएगा, so it does not accelerating admixtures do not ये वो एंटी फ्रीज का काम नहीं करता है। What does it do? It accelerates the early strength development before the freezing point is reached. So we use it in harsh, cold weather ताकि कंक्रीट जल्दी सेट हो जाए, और इससे पहले कि रात को एट द नाइट टाइम टेम्परेचर्स माइनस में चले जाए, उससे पहले ही सेट हो जाए। अगर अभी सेट नहीं हुआ और पानी उसमें अभी वाटर फॉर्मेशन लिक्विड फॉर्म में है, तो वो रात को पानी फ्रीज हो जाएगा, और अगर वो फ्रीज हो गया तो उसमें जो मैंने इससे पहले डिस्कस किया है, it will then break apart, it will disintegrate into, and there will be honeycombing as well, and there will be further disintegrations happening in the concrete after